This is example F from our properties lesson, looking at a positive x squared function. An x squared function, again, means it's degree 2. Positive means we're happy, our graph is opening up. We want to find a minimum. So under our calculators, we went to the calculate and we went down to find the minimum value. We were asked to guess from the left side of our minimum value. So we went to the left side of our curve, we pressed enter, and our calculator drew a nice little triangle that points towards the minimum. And then it was asking us to be on the right side of the minimum value. And when we went to the right side, we pressed enter, and it gave us another triangle. So the two triangles point together, and we're supposed to guess for the lowest point of the function. And when we do that, our calculator, it goes to the very bottom of the curve, and it starts blinking at the very bottom. And then on our screen, it tells us that we're blinking at +2. So the x value is +2, and the y value is -8. So we're blinking at 2 and -8. So the minimum value of our function is -8. The range of our function, all of our y values start at -8, and all the y values go up forever. So when you communicate the range, all the y's are -8 or more, or y is greater than and equal to -8. Again, we're not really spending a lot of time on domain right now. There is no square roots of negatives. There is no dividing by 0 for any x value. So our domain could be any real number. Algebraically, I try to start off by factoring 3x squared minus 12x plus 4. I realize that nothing multiplies to give me +12 and adds up to -12, so it's not factorable. So I know that I can always rely on my quadratic formula to find an exact answer. So again, I'm learning the formula. I wrote down what it is, -b plus or minus b squared minus 4ac all over 2a. I go back to my equation. When I look at my a value, it's 3, my b value is -12, and my c value is +4. A is 3, b is -12, c is 4. Put those numbers into the formula. The negative of b gives me +12. Then I put -12 squared, and I know 12 times 12 is 144, and then 4 times my a value times by my c value. When I work things out underneath the square root sign, if I did things properly, 144 minus 48 is 96. I look at 96, and I know that 96 is the square root of 16 times by the square root of 6, which is 4 root 6. So I have 12 plus or minus 4 root 6, all divided by 6, and all of those terms, they all divide by 2. So I take 12 divided by 2 is 6, 4 divided by 2 is 2. I don't change the root 6, I'm only changing the whole numbers in front, the coefficients in front, and the bottom 6 divides by 2 as well. So my 2 points where I'm crossing on the x-axis are right here, and one of those points is 6 minus 2 root 6 divided by 3, and the other point is 6 plus 2 root 6 divided by 3, and the bigger ones to the right and smaller ones to the left. So those are my 2 zeros. And finding the y-intercept is the same as we've done in all the other examples. If you put x equals 0 into the question, the y value is 4, so 0 and 4 is the point that's on the y-axis. Wrapping this question up, we need to still say what is our vertex, where is that point of the lowest or highest. In this case, again, it's 2 with -8. And the vertical line that cuts our graph in half, again, it's vertical, so it's what x equals. X equals 2 because our line of symmetry always goes through our vertex. And if the vertex is at 2 and -8, symmetry has to be x equals 2 as well. And that's it for our examples on the properties. So now it's a matter of looking at all your information, looking at all 6 of your graphs, and deciding if there's some things that are easier to do with your equations in this format, or if there's some other format that we want to start investigating to find some other properties.